US exports about 18 Bs of gas every day. In 7 days, that's the equivalent of the entire US consumption of gas. That's how much they're exporting to Europe right now.
Oh, wow.
So now you're going to have a battle between AI data centers, right, who want that gas for their peaker units. Then you're going to have LNG, which is exporting to TTF contracts in Europe, right? And so now you have a mismatch, a battle of gas is starting. And guess who has tons of gas?
Yeah.
Us. We export about 8 Bs of gas, right? 99% of our export goes down there. So it's like bullish gas as well. Like, we got to build a goddamn pipeline for the gas. It's
Yeah.
not enough. But secondary of gas, crude and heavy barrels, like drill baby drill, is going to actually end up happening in Canada more than US.
Welcome to Nerdin Out. Today we've got two outstanding guests joining us, Bakshi and Mike Henry. Bakshi brings deep expertise at the intersection of energy and technology, having built his career on unlocking value through smart data, system integration, and operational transformation. Mike Henry, meanwhile, has decades of hands-on experience driving innovation in the oil and gas industry, particularly in making complex data flows practical, reliable, and actionable in real-world operations. Together, we'll unpack how the value chain of data from capture to AI can transform workflows, how clean and contextualized data sets overcome industry silos, and whether AI truly lives up to the hype in oil and gas. Welcome to the podcast, guys. Yeah, great having you guys on. Excited to jump into this. So let's start. Mike, do you want to tell us a little about yourself and what you want to talk about today?
Sure. My name is Mike Henry. I'm from Calgary, born and bred. Been here forever. I'm I'd say a technology nerd, maybe used to be a technology nerd. I spent a career in building solutions for organizations that helps unlock the value of data, educating users on what that can mean, how to introduce workflows and optimize those over and over and over again, and really trying to find the divide between what is the business problem, what technology we need, and what people do we need in order to introduce those and adopt them and actually gain value from them.
Awesome. Very cool. Wish, do you want to introduce yourself a little bit?
How do I follow that up? 20 years of Calgary, born and bred too. Are you second or third generation?
I am second.
Third. Beat you on that one. And so I guess been in the power and gas industry for about 10 years now. That's where it started off. I build AI systems. Everybody goes like, what does that even mean? Essentially, it's like, just imagine a whole bunch of rocket scientists building a bunch of rockets in the garages. I get to tell them if they built it up to spec or not, or if they're going to blow up my rocket or not. So I get to play the bad cop. So I focus on two verticals, pretty much just in energy and AI. One vertical is on the operation side, so we'll talk to some of the upstream and midstream stuff. And then the second one is on commodities trading. So spend half my time down in the US and half my time up in Calgary, mostly around the C-suite, which is basically showing them the art of the possible, and then execution and delivery.
Very interesting. Very cool. Well, I think it might be a nice flow to start, talk with Mike a bit about the foundation of data and how that flows into AI. Because I think you're kind of building out the foundation with a lot of your clients and what you're trying to work on that kind of enables them to actually maybe tackle some of these AI problems, right? So it might be a nice flow. Kind of start with some of the problems you see and what have you seen in the last 10 years from where you started and how that's kind of progressing?
Yeah, I think that a lot of the marketing material out there says that we can do this, we can do that, and for the most part, I think the technology aligns with the marketing that exists today. So a lot of stuff that people are asking for, it's been around for a long time, and so I don't think that technology is definitely, it's not the limiter in what's possible. I think that in organizations that I see today, it's around how do you incorporate these tools and these technologies into your day-to-day. And a lot of times what a user might ask for, or what a company might ask for, is possible. However, the way that their systems, the way that their programs, the way that people use their day-to-day, the data that they capture, how they capture it, it doesn't necessarily support, as it stands, the ability to unlock value right now. Because they're saying, we've got technology, it can do it. You're like, yes, it can. However, you've got a few steps to do to introduce in order to grab the data, attain it, educate people on what that means, trust it, and then build the tools, technology side, to unlock the value that they're chasing. And so, in my world, I do see I'm not sure people realize the journey that it takes to actually get there. And you can build a project and you can do a use case. And I think those projects are great, and they give insight and they give education. They say this is what's possible. But I think from that point, you have to stop and say, what is a portfolio of things that we have to do in order to sustain this in the long term? And I think that corporately, there's a bit of education that you have to instill in people that says, this is what's required and this is what actually has to change within your business daily in order to in perpetuity, see the value that you're chasing.
Yeah, absolutely. And do you see like that that the clients you're working with, they're looking for major step changes in their business? Like, we want to see our business model change. We want to see new revenue growth. We want to see how this technology, or is it workflow improvements? We want to be more efficient. We want to not have to scale these teams as large as our regular, the business model we're holding today continues to grow.
I think the answer is yes, yes, and yes.
Yeah.
I think they want to see the value right now, and they want it quickly, and they want it cheaply, and they want to see value. And part of the challenge is educating on what value they're chasing. And a lot of times it'll sit on your P&L, so you can directly see it. It's a cost savings, it's less capital, it's more revenue, it's less OpEx. Those ones are easy to navigate. The tough parts are, what is the value that you don't see? Is there efficiency? And if they say that, we don't want to grow people at the same size that our company's growing, how do you measure that?
Yeah.
And how do you quantify the dollars that you're going to invest into an environment or into a solution stack where you can't tangibly see a difference? Because if I'm spending 100% of my day doing my workflow, and then somebody takes off 20% of my workflow, and it makes me more efficient. Yeah. How do I measure that 20%?
Yeah. Yeah, because they're still paying you. It's not like
they're still
you're
paying
pay that guy
so,
80% of his salary.
And so you hope that there's an indirect correlation between user efficiency and corporate productivity and value. In some form or fashion, that is a very difficult measuring stick.
Yeah. Do you have any examples of how you have come up with how like being able to measure that in anything that's been effective?
Yeah, like you can do pre and post workflow examination. So I've got a workflow that says, hey, you sit somebody and you have a stop, and I'm exaggerating a little bit, but you have a clock and you're just like, how long does it take you to do this? Start the timer.
Yeah.
Stop the timer.
Yeah.
Those ones are easy. You can measure things in terms of life cycle. So in oil and gas, there's got big life cycles. There's reserves evaluations, there's budgeting, there's forecasting, there's and all of those things require decision making. And some people do it twice a year. Some organizations do it quarterly. Some organizations do it monthly. So if you can measure the frequency of decision making, and so if you can say, let's improve your forecasting, so then instead of twice a year, you're doing it 12 times a year, under the same, the amount of effort or inertia that goes into that is the exact same. Well, now you've got 12 chances to make better decisions for your organization. Yeah. How do you measure the value of that without knowing the decision that you would have or wouldn't have made if you didn't do that 12 times a year? Yeah. And so I think there's ways you can measure the frequency of decision making as a proxy to value. Like,
he's totally right. I mean, you started the question pretty nicely. It says, hey, like, before you do AI, get your foundation ready, like your founding principles, your let's just say like the concrete and the plumbing has to be all done, right? But then somebody like me comes in and I'm sitting like, just think about it. Maybe I'm the guy sitting in the kitchen, like a sous chef comes in, the water's not flowing. Well, I'm dead in the water. I can't make any, I can't make any paella, I can't make any fancy pizzas or whatever. And so the idea over here is like, the last thing you want is the plumbing is not done. You bring an AI engineer inside and you kind of go like, oh great, I'm paying your top dollar, but the water is not flowing. So what do I got to do? I got to rip the wall apart, fix the plumbing to get the data. The analogy that I'm giving is that the plumbing is the data pipelines that, and so like in greenfield projects, it's literally what we are seeing, at least what I'm seeing is like the C-suite go like, we want to go AI. I'm like, okay, what do you want to do with AI? Productivity enhancements, or do you want to do tangibles, which is like your EBITDA targets, for example, or revenue ops? And then inside oil and gas, like, they have a commercial group, they have ops group, right? They don't talk to each other. So now it's like, okay, do you guys want to merge this technology together, or do you want to do vertical silos and then merge it later on? Again, that's the final stopgap. That's the final, way of doing things. But you can't do any of that until your foundation is ready.
Yeah, absolutely. So can you talk a bit about some of the more in depth on a couple of the projects that like you're able to speak to a bit on, like what was the was the water flowing when you stepped into those, and what are some of the challenges?
It's one of the things that we always do. Like when I go in, I say, the C-suite or the board will usually bring me in, and they'll say, hey, we're tired of kind of spending so much money on, getting a vision and a strategy. Is like, can you actually execute, right? Beyond a POC. And okay, so I'm going to table this conversation by saying something. POCs, like proof of concepts or MVPs, et cetera, in AI are quite different from everything else in data, right? And the reason is because, let's just say you build like a Power BI dashboard or your quarterly reports or your financial reports, or even like connecting to your Pi system and building a Power BI report that just gives you analytics, right, on an end-of-day basis, or even for trading, like end-of-day mark-to-market values or P&L reports. At the end of the day, when you build this thing, there's a final report that's going to run. It might be a shitty report, but it will run. With AI, it's an R&D activity. You have absolutely no idea. Like with the thesis, you kind of go in and you say, we're going to go design. Now, Mike mentioned something which is like OpEx, right? Guess what? AI does not even qualify for CapEx. It's R&D.
Yeah.
Right? So how do you budget for that? How do you forecast that? How do you manage expectations? So when we started that first order, just coaching the executives in the C-suite, this journey is quite different from everything else that has ever been done in analytics and data, period, right? Then the second one is kind of like going in and opening the chamber and saying, okay, they have a vision, and they say, I want to tackle this problem. What we call like the A+ and the B+ problems. A+ are like the moonshot ideas. And the idea over here is like, oh, great, like you want to do this 10x, ROI AI use case, but you do know that there's these B+ problems that are sitting in some midstream assets, for example, or even upstream assets that you just can power through in 6 months, right? Like, do you want to go do that moonshot idea or B+? And so the idea over here is like, go with a B+. Now, figuring out what those B+ problems are is an art, especially in oil and gas and midstream assets, even like refinery ops, right? Like blend book strategy, or like how do you blend? How do you actually get ready for winter season, et cetera? And so that's where you have to massage and figure out, what the use cases will be.
Yeah, absolutely. Especially as you see, like underlying technologies and techniques can change too. So then those B+ becomes even more questionable, right? Oh, okay, we're looking in. We're on the completion side looking at frac, and it's like, well, maybe they want to shift from their zipper fracs to a different technique, and then you're like, well, now these B+ things are not as tangible because it's like, well, we're not even going to be doing this in 2 years, or who knows, right? Like that's where you got to really dive into those things and figure out, like, okay,
asking those
are
questions,
you sticking with these techniques? Okay, now let's try and optimize it.
Yeah, exactly. And you have to figure out is if Mike comes in and we're connecting to these source systems. It's called the ETL layer, like extract, transform layer. You're bringing it up to the cloud to do some of this analytics, not even AI. Figuring out, are you going to run this once a day? Are you going to run this once a week? And then on a Q over Q basis, like, you have your decline curve rates. So it's like, well, if I deploy it on these assets, are they even going to be functional in about 12 months, right? Are we going to go through shut-ins, right? Like Montney is a big problematic area right now based on like some of the ramp-ups of some of the other assets. So yeah, you got to have these conversations.
So going back to, we were saying setting the expectations on those B+. So can you walk me through a bit on like what those conversations kind of look like? Because when you're looking at these, even the A+ or the B+, right, you're just like, well, we think we can do this in 6 months. But obviously, yeah, it's R&D. Like we're going to see if our hypothesis holds true. If the plumbing's good enough that when that data quality comes through, it doesn't just break the model, right? We have to do all these things. So how does those conversations kind of go and keep those expectations?
Okay, I'll talk more on the operations side because obviously that's where all the some of this conversation. Trading is just going to be a whole different beast. But on operations, you kind of go to the hard hats. They're going to tell you exactly which problems they're kind of facing, the blue collars. At the end of the day, they're on the site. They're going through all the nitty gritty. And the B+ problems will be like figuring out which assets are being underutilized, right? Your NPT, non-productive time, right? Like that's a very key metric for everybody. It's like that asset has a high NPT, right? And then you kind of dive deep and say, okay, is it because of sensory data? Is it because of bad data? Or is it actually the physically, the frac site is not set up properly? Like what is it? And then you kind of start going into it and say, okay, can we replicate this model because of these specs are replicated in other well sites as well? And if that is the case, then you kind of meet something called scale, right? Because now you can take this model that you built for this problematic asset and you can rinse and repeat it. That would be something like a B+ problem, but you got to pop the hood and look at the data first and say, okay, the data is actually something that we can manage. Yeah.
So you kind of go in maybe as like a consulting contract or something, basic where you say, okay, I'm going to do my first iteration and I'll come back and then we'll decide if this is actually worth tackling.
Yeah, it's a little bit higher too, right? Like a lot of times when you've done this enough times, you basically say that, here's 5 problems. Like which ones are you going through? And usually, like out of those 5, people will say 3 or 4 are already occurring, right?
Yeah.
So you already know where to look. It's just kind of telling them, do you want to go with this problem or not? Do you want to solve it? And they prioritize that on the index, and then you kind of execute on that behalf. Yeah.
Interesting. Do you find you have a similar experience, Mike?
Yeah, I think that what and I think so much of what Wish was saying, I think uncovering the opportunities is it's an interesting problem. I think that a lot of times what we've done historically, we've said, okay, how many opportunities exist in your business? And within a business, oil and gas is very, very complex. You've got subsurface, you've got drilling, you've got completions, you've got production engineers, you've got facility engineers, you've got the flow of data, you've got your egress pipeline to your sales point. So you've got many points in your business that I think are ripe for opportunity. Trying to uncover what those are and what's required to see it. If you want to measure the value of a project, I push that back to the team. And so if they said, hey, Mike, we think that we want to reduce completion costs by 10%. Show me where there's opportunity to cut it by 10%. Show me how much it costs for sand wrapping. Show me how much zipper fracking costs. Show me how much MPT time. Show me how much. Okay, we want to look at MPT. Okay, how do you make the decision on how to reduce MPT? And they might say, okay, what do we need? What do we require for that? Well, do you care about drilling data? Do you want to see where they had difficulty in drilling in areas that may affect stages 5 through 10? Okay, do we have access to drilling data? No. So if you want to quantify and measure the value opportunity for those, what data is required to help them with decision making? So a strategy might be to push that back to them and say, what is the value of solving this problem for you? And if MPT time consists of, let's call it $50 million, how much do you actually think you can save? Because it's not taking it from 50 to 0.
Yeah.
So if that problem is, okay, Mike, I think we can shave $2 to $3 million. Okay, show me how you would save that $2 to $3 million and where.
Yeah.
And do you have the data to support decision making? And Wish said, okay, it could be a data problem, it could be an analytics problem, and I think everyone jumps to AI. I'm not sure that's the first hop. And you might say, yes, we can quantify that through a visual, Power BI, Spotfire, you name it. We think we can see that there's a distribution problem on this data, and we think there's certain. Okay, good. Let's dive into that. And so all you're doing is you're just narrowing down the problem that you're looking at and the question that you're looking for, because AI cannot solve every single problem in that chain. It can solve one of them. And so I think the trick is to figure out what data are we looking at, what supporting metrics do we have, and what question could we ask that we can then do research on to say, okay, let's see if we can figure out if AI can actually identify the problem and predict it and so forth. And so then, okay, you might have an example that says, okay, we've got a very narrow question. It's a very small question. You answer it, we think we can do it. Okay, now it's, if we're going to do this in perpetuity, what data is required to do that? And so the learning exercise is, we required data A, data B, data C. We have A, we don't have B, and we don't have C. How do we acquire it?
Yeah.
Typically, that's a different group.
Yeah.
And so then you chase this upstream problem and all the workflows that people do to generate and manage that data set that eventually flow into the problem that you just solved. And that window between when I think we can answer it to when we can actually put it in production and answer it on a regular basis, there's a time window there.
Yeah.
And those exercises for me is more like a learning and a look back that says, what did we understand? What did we learn? What do we have to adjust? And in the meantime, let's limp this along. Because the last thing you want to do is have expensive wishes there.
Yeah.
making this thing-
Whoa. You don't know my hourly. You don't know my hourly or my...
You don't want them managing and supporting this thing 24/7. And so then you got to think about sustainability and the resource that you require to get it through the door. So and I think the education portion of it is maybe what I'm getting to is, do organizations understand what's required to actually attain the value and then keep it going?
Yeah, that's really well said. I think, so do you find like in the kind of projects you take on, in a lot of ways, you're kind of a coach for them, just trying to help coach them through this process? And
Well, I wish I had my coach Mike water bottle.
he's actually a coach.
Yeah, I'm
right?
actually a coach.
He's actually a ball coach, yeah.
So, and without feeling like marketing, but when I started this company that I started about a year ago, I have a passion for tech, I have a passion for people in business, and I have a passion for coaching. And many times my job was spent just teaching people about what this is and what it meant and what has to change. And so a big element of what I think that I have to do, and I'm pretty sure what Wish has to do, is just educate people on what it actually means. Anyone can pull up an article and it's like, oh, this company did that. I think you get the shiny object report, and they don't go into the dirty details of like the diamond that you pulled out of the stone that looked like coal, and you had to grind it and get into this beautiful shape. So part of it is just educating people on what is actually required to keep this in, and to keep value, and not only to keep value for the project, but to build a portfolio that says this function should be within our organization permanently.
Yeah.
And if we teach people how to look at problems differently and to solve those problems, then the value chain of data, and I think that was a bit of a topic, which is what's required upstream, how do you manage the data, how do you get access to it, how do you analyze it, how do you build AI programs, and how do you get those out the door? And every single one of those places, I think, brings value to your organization.
Yeah. Do you find that when you're going down this path and say you're getting like through a few steps, but then you're kind of still tackling that question of like, do we need to sustainably put this measure within, that you see a lot of companies kind of falling into sunk cost fallacy? Well, we already invested in like producing these things, so let's just put it in. Like, why wouldn't we? And you're like, well, it didn't really prove itself, right? We tried, it doesn't make sense to continue, and you have to kind of.
But I think that's a worthwhile question.
Yeah.
If you invested the dollars and it wasn't there, should we keep going?
Yeah.
I mean, in oil and gas is a very expensive business. There's lots of capital dollars, and everybody has to fight to make sure that the ROI is there. Whether it's the drill bit, whether it's a facility, why should a data program be any different? And so the difference would be that if there was value there that you couldn't attain, why couldn't you?
Yeah.
If that answer is because we didn't manage everything before it that we needed, okay, do you think that the value that you were chasing here is worth investing in that to retry this problem in 6 months from now?
Yeah.
And do we think that there's going to be value out of the 4 things that we're going to get that lead up to this? Is there value in each one of those independently?
Yeah.
If that answer is yes, sure, start the car.
Yeah.
And then once you get there, try it again.
Yeah.
And maybe you'll flip a coin and maybe it'll work, maybe it won't. But hopefully that those projects A, B, and C before you try D again, maybe each one of those independently has value. And so if it's not worth it, don't do it. And if you talk to a reservoir engineer or a development engineer, they would say to you, we have to fight for capital to make sure this well is worth drilling. We're drilling for data, they're drilling for oil. It's no different.
Yeah.
Yeah.
Yeah, absolutely. Which do you find, I think Mike touched on a good point there of like, you're going through in analyzing this data and figuring, okay, is this an AI problem? Or I'm sure there's cases too where you're like, actually, we just need to surface the data up in a Power BI and the people can just make the decision. So do you find that you dive into problems and like, we want AI to fix this, and you're like, actually, guys, you just need you just need a dashboard.
All the time. And giving them visibility, like sometimes it's as simple as like an Excel spreadsheet.
Yeah.
Right. Like you normalize SCADA data, sub-second to 5 minutes or 10 minutes, and you show them an anomalies, and they dump it in an Excel spreadsheet, and they analyze it and be like, oh yeah, there's the problem, right?
Yeah.
But there's one thing I want to like just make it clear, right? That's reactive.
Yeah.
It's problematic because the damage is done. Like, what are you going to do now, right? I'll give you guys an example, like Screenouts. 4 fundamental pillars, like you have your treating pressure. I'll tell you exactly what happened at the end, and then we'll walk back. How painful it was, by the way, to like do this. So you have the treating pressure, you have the proppant, and you have the slurry rate. And then, I mean, you guys would know this better than anybody, but essentially what happened was like, we deployed an AI solution, 2 months, nothing happens, right? It's for screen-out detection. And then Joshua, who's just kind of sitting over there, it was a Power BI dashboard. So the output of the AI model was in a Power BI dashboard. And he sees like probability of failure, right? 50%. Like 20 minutes go by, probability of failure, 75%. So it's like kicking up. So you guys go like, okay, do I kind of take action over here or what? So what happened was, like, the way we had kind of built it is like rate of change, the speed versus acceleration, right? And the model was picking up on a whole bunch of hydraulics, et cetera. And it had never been detected. So he kind of like yells down and be like, hey, ease off on the pressure, right? And as soon as like by 5%, what happened was the PSI pressure went up to 1500.
Oh, wow.
Like that, right? So what happened was the formation wasn't taking the liquid very well. That's kind of how he explained it to me. And so the thing was, because of that, they were able to like take predictive measures. And then we did the NPT analysis and everything. It was about 250K, right? And so it paid off dividends. But for 2 months, like easy as she goes, right? Like nothing happened. But the painful journey was actually like getting into the nitty gritty, right? When we built the system, first problem that we ran into is like, you know how we started showing you like the probability of failure? Like in the dashboard, the very first model we deployed, they freaking hated it because it's like probability of failure, like WTF, like why, right? Like, so then we were just like, oh, we got to go back to the drawing board and give them some visibility on how the model is kind of trained, right? And so then we fixed that problem. Now going even a higher level, the first time we did it, all the clocks of all the systems, not in sync.
Yeah.
Right? It's a common problem. So going back to the original conversation was like when we did the ETL, we were like, oh, some of this stuff is in mountain time, some of this in UTC. The clocks are not synced for these SCADA systems. So we were just like, well, we pump it out, like we got to normalize it, right? And this is like second level data. So we had to normalize that. Then, like I'm going like backwards, right? Like these were like stages of how we had to fix the problem. But when we first got into the drawing board, we didn't even want to solve this problem. Like what happened was, it was just like, hey, we want to do analysis of seeing historical pressure deviations and see how it works on a per asset basis. And when the original solution was an Excel spreadsheet. But what happened was when we were digging into it, the operators started telling us about assets that were problematic, and they had screenouts on certain assets. And that's how the use case came to be, because initially they had a different problem statement, but when we started looking at the data, we were like, hey, like, you know, you actually can solve all these other problems because you actually have the data for it. So yeah, like, you know, going back to your original question, it was just kind of like, the original thing was an Excel spreadsheet, but when you look at the data 9 times out of 10, like all these other use cases come out and they go like, oh, we can actually build a system. But it's never easy, right? Like modeling is different.
Yeah, absolutely. Can you speak a bit what kind of model you're able to share that?
So the first time we actually we made a mistake. This is like almost 2.5 years ago. We built a neural net, in like an LSTM time series model. And the problem with that model was that it gave zero visibility of how it was coming up with these conclusions, right? Like neural nets are
Engineers
notorious.
don't like that.
Yeah, they don't, right? And so, but it was really fascinating because when we built it, you know, the understanding was here's the number one thing that I would always recommend. If you're building a solution, a data scientist is never the end user. You're never the customer of your own product. It's somebody else, right? And so you have to have like those weekly checkpoints. So they knew what we were building. They just didn't know that it's a black box, right? So the first iteration that we did when it was giving the score, actually the LSTM was a time series model, so it was just giving values, but then we brought a probabilistic model on top of it to give the probability, right? Like LSTMs don't give you probabilities. So anyways, like the problem was like this number would blast out. Yeah. And they would be like, WTF, like what am I supposed to do with this, right? And then so we went back and we built like decision tree models, which is simple, right? Works. And it gives you explainability, right? And so now the other problem that we ran into was like the data quality issue was like very bad. Because there were certain sensors that were like have issues populating. So we had to filter out which sensors we could do. Because some sensors were really, really freaking good. But the problem was that data quality wasn't very high. So we had to kind of like iterate and be like, oh, the model did really well. The problem is like it doesn't give you like consistently highly accurate because these features, these sensor data that is going in is problematic. Because you can do like imputation and all this other nerdy stuff, but it's whatever, doesn't matter. So we had to like filter out, and then we were like, okay, there are second order sensors that are consistent, but not nearly as good for the model to generalize, but we will use them. So it went to it, but again, you know, discussions after discussions, multiple iterations, and then the hardest part that we haven't got into is building a model is not that hard actually in today's world, right? Like if you actually have the first principles and the math and a STEM, it's sustaining it, right? Because a Power BI report that you build or a Tableau or a Spotfire, you know the plumbing is working and things are not, if they break, you know where to look, right? But what if somebody goes and does a maintenance on that and changes like some of the underlying features that are required for the model? Right? The model is going to behave completely, like the thermal dynamics for some of the sensors are going to change because it's a new part, for example, right? And so that sustainment strategy is where like things fall in AI. This is about like attrition rate in energy is about 95% of failures, like from POC to just dead projects in AI, because the sustainment part is what people haven't figured out yet. And that's kind of, the system changes and the data changes, the maintenance happens, the catalogs, like the whole thing, right? That's where the real value is, and that's where people don't focus.
So within your screenout detection, was there any examples of like where being able to sustain it, like things you have to monitor or things you brought in to be able to sustain it?
Yeah, I mean, I have to be careful how much I can disclose because if my client's listening, I'll get into some trouble.
Of course.
You know, but I guess like what we did build is a monitoring system. But what we did was like there's a primary system, which is actually it was Spotfire, And then the secondary system was monitoring all the sensor feeds that are going in. And it basically kind of like showed you the distribution of all the sensor kind of going in, right? So the feed. So you knew that if there was a problematic, like if it was kind of giving you like 85% failure rate, you know where to look to say, okay, is it is it a input data quality issue, or is the model actually accurate, right? So, but you run into a different problem, right? Like the ICS and DCS and rocks, like the command centers, they don't like having so many dashboards to look at, right? So we had to like figure out how to figure that problem out and normalize it. But it's just like you solve one problem and two more show up.
Yeah, absolutely. How do you go about like you tried LST model and then it wasn't working very well? Like how do you think through like which model should I try today?
So, model selection is something, first of all, if it's black box, like traders, like who I work with, right? They freaking will never work with neural nets.
Yeah.
Right? Because again, explainability. They'll be like, I'm a quant, they're the fundies. So there's always like, have you guys seen the movie, like the show Billions? Right?
A little
like,
bit.
Yeah. Okay. So there's like the hedge fund, and he
yeah.
has a fundies team who run by like traditional like Excel spreadsheets, and then there's the super smart quants. They don't like each other, right? I got humbled 10 years ago when I sat on the pit in the trading pit, where these fundies people, they just know so much.
Yeah.
Like just off the top, they'll see like that forced outage over there on that asset over there is going to cause problems over here. The spreads are going to go here, right? Like just like that. There's no neural net that can beat that. But what you can do is like give them ability to transact a lot more frequently because they don't have to do all that analysis and the data is kind of flowing in. So going back to your original question on model selection, it all depends on how much visibility and what the use case is for the customer. Like there's so many models right now, right? And again, like building a model is just like, I don't know, like 20 lines of code for, putting it into it and building it out. The idea would be like, what does the customer want? They want full visibility. Well, then they got to sacrifice accuracy, right? Because, and especially if you have like really, really large, like big data sets, neural nets are amazing for that. Yeah. Smaller data sets, not so good, right? Like, and here's another one, like good way is like, if you want to do anomaly detection on an asset, how many anomalies do you have logged in your system for a model to learn?
Yeah.
So there are like very, very specific techniques that you use to kind of tackle those problems. So again, it goes back to the use case of model selection.
Yeah. So when you were looking at the Screenouts, like, did they have that tracked already? Because
no, you had to build it.
Yeah. Okay.
From scratch, everything. Again, learning curve, right? So this is almost like 2.5, 3 years, and I've done about like bunch of Screenouts since then. And so every iteration is an improvement. But the initial one was like when we did the first one to the second one, the improvement for the second version was about 80% more, right? Oh. But over like as in like we figured out there's all these things that they care about. Yeah. But then the next bunch of 3 or 4 or 5 iterations we did, the improvement was only marginal, right? Because you've kind of figured out the plumbing. Yeah. I think he wants to say something.
So Kohlberg has been around for a long time. I think you provide a service that is well needed in oil and gas. In terms of real-time data, in terms of real-time decision-making, during completions activity. What types of questions are your clients asking in terms of how to integrate those data sets and what challenges they're seeing across that value from rock to drilling to completions to, at the end of the day, productivity for the wells? And where do you see customers on your side asking questions and what do they want next?
Yeah, so I think it's probably, you see like two big sides to this. One is like trying to find that very narrow question, right? So I want to understand pressure phenomenons, or I'm looking at something very specific that a completions engineer might be looking into. The other side is like, especially with the larger operators, they're saying like, we want, a very, like getting more sophisticated data layers that bring all of these, if we're running 10 fleets at the same time, we want all this data coming back and we want to understand it. We want it standardized across all these different fleets, which they really didn't have before in a lot of cases. And so a lot of it's like building that up. I want this simple, daily report that I can look at and say, okay, how much MPT, what am I spending my time on? Where is there a place that we can save money? And I want to see it from every single fleet, and then starting to compare between fleet to fleet. So some of these things that, maybe are standard practice in a lot of other industries, like they weren't really there, especially in the completions where the data sets were so divided for a long time. And so now with how we bring all the data in, these next steps aren't that difficult because we've already, dealt with all the time syncing issues, and now we automate the time log for them. So there's a lot of that human error where people put, they're saying, oh, this is when we started a frac, or this is when I did my ISIP, and it's all kind of manual. And then as additionally, as we see like techniques change and new technology comes in, it makes it really hard to try and keep it all into a standard data set. So we always have to try and grow with them, right? So like, oh, we're going into simulfracs and trimulfracs. Okay, we got to grow our data. Okay, we got to make sure our data set can work with that, and we can still like standardize and understand. Okay, when you simulfrac, you don't just entirely simulfrac. They'll run both frac fleets, and then maybe one has some downtime, and so they have to like be able to differentiate. Okay, well, why did this one have this downtime, but this one's still fracking? And now with the advancement into continuous pumping, it's kind of putting in this new question into, okay, if we're continuous pumping, what does that really mean? Because and you see, there's some good LinkedIn posts and people are like, oh, we pump for 24 hours a day.
Right.
It's like the pumps were running for 24 hours a day, but did you stimulate
you
this
weren't pushing
well?
sand for 24 hours.
No,
Yeah,
exactly,
yeah,
right?
yeah.
So they have to, now I was like, okay, we got to reevaluate how we look at this. What is actually the value driver? And it's stimulating hours, right? So it's like, okay, well, maybe we can put out and then now it's like, it's those intangibles with people want to put out the hype of pumping 24 hours. So you got to like build that into reporting too. They can still say pumps were running 24 hours. Great job. All continuous pumping swaps. But how much did we actually stimulate, and how much time did we save from a traditional zipper frac swap versus this continuous pumping swap, where it's like, oh yeah, pumps were still running, we opened the next valve, but okay, well, how long did it take you to close the previous valve and get going again? Right. So a lot of interesting things as we see the techniques evolve, simulfrac, e-fracs coming out. So it's always like trying to expand, trying to help them capture that next thing and look into these next pieces.
Have you guys looked at, and I've done a few different examples in terms of completions activity, where you can make a prediction on a screen out, but by the time you made the prediction, you were 2 minutes behind because of the time travel that it took to get from surface to the bottom. So have you guys looked at doing things around like almost real-time decision making, somehow baking in the delta between when the sand left the pump at the surface and when it actually landed at the stage? That makes it easier so if an operator, it's like, oh, I noticed a problem, missed it, too late.
Yeah. I'd say not too much yet, but
Okay.
that is kind of like where I see the next steps really coming.
Right.
Now that I think the data sets are getting really good and the quality of the data is getting, which is a problem. I mean, we're still working on it. It's not perfect, but is getting to the point. And what we see too is like there's always a divide within the companies that we see where it's like they have a data team. The data team doesn't talk to the completions team. It doesn't talk to this team.
Typical.
And like, oh, we have a great model, but we can't run it in real time.
Right.
And it doesn't incorporate back into where
Right.
the OSR or the completions engineers actually says, oh, okay, I can make a decision now, right? So I think that's still coming. Like that I haven't really seen that come to fruition yet.
And if you had to pick, the last question, and is there any, and again, I'm coming from a bit of experience where, like the AI side for completions for the stuff that I've done historically was more in support of planning and delivery than it was in the real time execution of things, just because of that delay. Do you see any movement in stitching together, maybe for cold bore where, downhole telemetry, we can actually see what's going on in real time. You've got fiber, you've got, let's say, dark vision, but that's after the fact, where you can incorporate that into your guys' operations, or where do you see that incorporated into frac providers, that they're going to introduce these data sets or these types of activities?
I think like the big data is always a really big challenge. So if you look at like dark vision, where they go in after the fact, like they had this huge data set, so it's really hard to incorporate into the real-time systems. Or if you look at fiber, where it's so much data on site, we can't even get off-site without incurring so much cost that it would invalidate any
The egress cost is going to kill you.
Yeah.
Or you blow through the fiber.
Yeah. But what I do think is coming is where I think what we see, where especially in the Permian, where I think in Canada they're more particular about their fracs, about their stages, because they might have 3 pads a year. In the Permian, they're going, Permian, it's
we know better. We know better.
Oh yeah. But in the Permian, it's a conveyor belt, right? It's a factory. It's like you got 48 hours to get to the next pad, and then we're going to go stage by stage. And so there's a lot of like some of these decisions where they think, oh, maybe the plug slipped, but the time it takes for us to get this information, make a decision, it's like we lost all that value
All that
just in the
sand.
decision
Yeah,
time.
totally. Yeah,
so it's
yeah.
like just pump the sand into the stage and go on to the next one.
Right.
Like
Don't
we
worry
don't have
about it.
time to
Law
think
of
about
averages will
each
work
stage.
out. Yeah,
Exactly.
yeah.
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 So I think that will change over time as as the data gets better, as planning can get better, and there's better communication between reservoir completions and production.
Right.
Where right now I think a lot of these teams they work together, but they're also separate. Reservoir says here's the plan. Completion says okay, we'll frac close to that plan,
Right.
and we'll kind of
Adjust it a little bit.
as we feel.
Right.
And production says, okay, I got the oil, looks good, or whatever.
Right.
But where we see an issue, okay, we need a new plan. Well, I don't really see that happening. Not really, like they are a little bit, but not like it's more from. I have this knowledge because I've worked in it for 30 years. So
Right.
I understand like intuitively
Right.
I can make a decision here,
Right.
but not data-driven decision.
Right.
And I think that has not happening yet, but I think that's coming.
Do you guys like coach them through their use cases and the difficulty? Like, do you rank order them and say like, listen, if you want to do this, or do they come to you with a problem and you say like, fiber problems, like blow the damn fiber out, or egress cost is going to be too high? Like, what does that relationship look like?
Yeah, usually they'll come to us with a problem, and they vary from we just want to understand this better, and so we want to look into it. So it's like, okay, we'll build analytic around it or a metric, and we'll try and start measuring this for you and bring it in, then you can start looking into those things. Sometimes I have more ambitious ideas where it's like, and then we have to think about, okay, we want to bring the fiber in. Okay, was that, and that one we did explore, but yeah, the ingress cost there is it just didn't make sense. It was like, hey, this is a huge cost incur, and we don't really know where the value is yet. Yeah. So maybe this isn't the right project to take on today. Right. So yeah, a bit of.
So you're doing exactly what we do, but just at the tail end, right? Like we coach, right, and say like, here's the foundation, and then when they come to you, you kind of coach them through of like the feasibility of that use case, right?
Yeah, absolutely. I mean, a lot of them are not developers, not AI people, not data people. So they come in and say like, I want this, and you're like, okay, this is what I see. This is the steps that we should start here, and we'll do like a small contract for that, and then let's see what we learn, right? And then go next step. So I think similar.
It's like building
similar
Lego.
levels. Yeah, absolutely.
It's funny, like all three of our chains is exactly the same.
Same problem.
Right? Yeah.
Maybe that's a good segue into our news topic. If we want to jump into that. So I found this article. So it's talking a bit about what's the next big step in LLMs and what the big, Google, DeepMind, Meta, NVIDIA, and OpenAI are looking at. So what they're talking about, that their big next step they're looking at is called real world AI. So they kind of speak to as well that ChatGPT 5 was supposed to be this big next step in ChatGPT, and that Altman was kind of saying this is kind of the predecessor to AGI. But when it came out, it was very underwhelming to users, and they found that from benchmarks and kind of experts testing this, that it really didn't. It was marginally better, and then the learnings kind of came out. It's like we think that LLMs are near as good as they're going to get with their current architectures and the amount of data that's available now. And they kind of speak to as well, like what they've been doing in the last 3 years is just more data, more computers, throw more data and more compute power at it, and they keep getting these huge big increases. But now went from GPT-4 was trained on thousands of NVIDIA chips to GPT-5, which was hundreds of thousands and way more data, and they're buying data from all these different companies, but they only saw a marginal increase. And so they're saying like, well, maybe AGI is much farther away or not achievable in the current architecture structures. So now people are kind of looking at, well, there's still a lot of value to be captured. Companies are still really not utilizing LLMs or AI in a large, into what's capable today. But now looking at what they're talking about is real world models where they want to pull in data from, and one really big example is the Pokemon Go, Niantic, where they have 30 million monthly users, all putting their cameras up and getting this very granular, high resolution data of the geology and geography everywhere in the world. And they're selling this data to, I forget who bought it. It might be Meta or OpenAI. And that they want to train models on this. And so some of the big progress that they see is having LLMs be able to really understand the real world and real world physics, so they can create videos and images that adhere to our real world physics. Because currently they really don't. They get an image and they kind of just, oh, I've seen a monkey before, I've seen a ball before, and they just kind of place things randomly with what understanding they get from that data. So pretty interesting model, but yeah, I'd love to get your guys' thoughts on what you think about
He's the
where this is
LLM
coming.
expert.
LLM expert. Wow, I haven't heard that one. So there's a lot of things over there that are just not true, right? Like this is a problem that I have. Like a lot of these media folks, they write these things without actually getting into the fundamentals first. Fun fact. So I'm going to give you guys like a bunch of facts. GPT-5 is actually not a bigger model than GPT-4o and 4.
Okay.
By size. Okay, that's one. It's actually the same size. Okay. The second thing is GPT-5 actually has a router built in there. Okay, so what they did was, and you have to understand, like, I'll tell you why they did it this way, but what they did was they wanted to essentially optimize their costs. Like the costs are killing them, right? So, for example, like if I have a $200 subscription for Pro, I can hammer it out and reason, but I'm paying for it. What they did was they built a router in there to say, hey, depending on the difficulty of the question, it's going to go to these different tiers of GPT-5. Okay. Now the reason why they did that is because there's not enough compute to go around. So essentially what they did was they figured out a way to get the best bang for the compute that they have. So today, I believe OpenAI has about 2 gigawatts worth of compute power. 2 gigawatts, so is roughly about 2 nuclear reactors worth of power. Now, you might think that's a lot, but it's not, because there's like God knows how many billions of users, right? Again, like Microsoft has its own data centers, but OpenAI themselves have 2 gigawatts dedicated to serving and also for training. Now, here's another fun fact. GPT 4.5 is actually a better model than GPT 5, and it's actually bigger.
Oh, interesting.
Most people don't know that, right? The problem that they ran into was that the user experience was really shit for 4.5 because it's so big. Go play with 4.5 and you'll see that the results are much better, right? Okay. The problem was that it's such a big model that the user experience of the next token word prediction, that's how the models work, it was just too slow. Mm-hmm. So that's when GPT-5 came out. They built a router in there because they said there's no computer around. Now, the second part that you kind of touched on is that they're running out of data. That is true, but the next generation models that are coming out are not going to be built on the same kind of underlying. So transformer architecture, attention is all you need. It's a Google DeepMind paper that was written back in 2017, and it's pretty easy, right? Like all it is like pay attention to this word with every other word. That's kind of how it's built. That's how kids learn. The new one that's coming out right now, it's reinforcement learning. Sorry, it's not new. It's been around forever. The father of reinforcement learning is actually from University of Alberta, Richard Sutton, right? And so if you understand like how they're going to do this now, is the reinforcement learning takes about 1,000 to 1,000,000 times more compute.
Oh, wow.
And what it does is it basically understands your environment, right? So it's a state machine. So you go from this one position to another, it will learn everything about the environment. It's not like typical pattern recognition. I'm grossly simplifying it. Neural nets are not pattern recognition, but just generally speaking. But reinforcement learning actually learns. And if you look at the words reinforcement learning, it just says that in the name. Like when you see a kid, right, and you have a child, and they're about to fall riding a bicycle, sometimes you let them fall so that they can experience pain. You let them make mistakes, right? Reinforcement learning is built that way, but it takes a ton more compute. We are just literally in the early innings of what's about to come, because that reinforcement learning, when the compute, all these AI data centers get rolled out, right? There's about 140 gigawatts worth of power generation that is in the pipe in North America right now, in US alone. 140 nuclear power worth. That's supposed to come online in the next 10 years. When was the last time we built a nuclear power plant?
I don't even know.
Yeah, it was like 5 years ago. In Canada, I don't know.
Oh,
but in US, it was Vodal, right? And it was $50 to $20 billion over budget. And they finally got it off rolling. It's in Georgia. Now, if you think about all that power and the NVIDIA GPUs, now the other part that you have to think about is, sorry, I'm kind of going on a long one, but there's like a whole value chain of what's about to come. Is the the GB300s are getting rolled out right now, right? The Rubin architecture, the Blackwells. Then comes the Rubin. So just to understand, these new ones are in a rack. There are so much compute that is compressed in there, and they're all getting rolled out, like Oracle, $300 billion deal, et cetera. They're all going to get these GB300s. Now, just think about like the biggest data center right now today is Colossus, XAI, which is Elon's in Louisiana. That's 200,000, right? They're talking about 1 million GPUs. Now, you throw that on reinforcement learning on one data center that is the size of 15 football fields. Think about how much inference you're going to have, right? The third thing is Claude. Like if you just look at the Sonnet 4.5 that came out yesterday, it can code for 30 hours straight now.
Oh, shit.
Like if we were running into a data problem right now, like why are they building all this stuff, right? Like why are they building all this infra? That's where the smart money is. So I think there's the journal stuff, and then you go to the engineers and you follow the money, and you kind of go like the entire ecosystem, every job is going to be fundamentally touched, but it's not going to be bad. I think it's going to be I'm very bullish about it.
Very interesting. Have you seen this talk on like the real world
Yep.
models? And what are your thoughts to
So
that
they're
point?
building a physics engine, right? So this goes back to what Jensen talks about, which is the AI. He calls it like this AI factories, right? And so the analogy that I would give is he's building a physical API, right? So robotics is the next frontier. Quantum computing is a little bit out, but robotics are coming for sure. And that's the simulation engines that they're building right now are built on that sort of data. And guess what engine they're going to be all using? Reinforcement learning. Yeah. Right? Like that is the pillar. And now all this compute is coming. And guess what? Like, you kind of, in the intro, you kind of hit it out of the park, which is the video, right? Like video is 4 to 10 times more information dense. Who has most amount of video? Google, YouTube. All the net new content that's coming out. Who's going to win that game? In my opinion, you have text in there, you have auditory, and then you have physical appearances, et cetera, and you have facial expressions. Who's got the best training data?
Yeah, you do. Yeah, for sure.
Right? And so the physical world is going to be built on a lot of these things. Like if I touch this right now, right? Like 3D, like how, like the models that are coming out now, they're going to be able to simulate this in a perfect little environment. And then you throw the robots out, and you can see it on YouTube and go on there to watch the videos. The robots are learning like this now, just like they're little kids. So like this idea of like that we're running out of data and all this stuff, no, not true at all.
Yeah. So we should look out for or OpenAI buying all Twitch's data or something like that.
I would say so. Yeah. I mean, Sora 2 came out, right? Like the app yesterday or today. I mean, just look at what it can do in your app. Like you can actually, it's freaking wild. Go on your phone, copy the HTML of any website that you like, feed it into Sora 2 on your phone. It'll generate the exact clone of that website now.
Wow, that's wild.
10 seconds. You have a clone of the website that you love. Like you can do it right now on the Chrome. You can go right click, go copy the HTML, put it in Sora 2 on your phone, and you'll have like a complete carbon copy of the website.
Oh, wow. Scam's going to get too good.
I don't know about that, but yeah.
Oh, very interesting. Awesome. Any other topics we didn't touch on, or Mike, do you have any questions or anything coming to your mind?
Not off the top of my head.
No? Okay.
No.
Let's talk. I mean, why don't we talk about like bullish Canada oil and gas?
Yeah, I'm down for that.
Like let's make it a Canadian story.
Yeah, absolutely.
I mean, so at least like being in two different countries, I can tell you this, right? Like I want to give. We talk about AI, we talk about data, but I think at the end of the day, the bread and butter for both me and Mike is oil and gas. It's energy. For me, it's power as well and trading. And so there is like the sentiment in Canada that oil is dying, energy is dying, right? Fundamentally, completely not true, right? And so again, I'm not going to talk theory or abstract. I'll give you guys these tangibles. There's something called GOR, gas to oil ratio, right? The Permian is dying. Like you can look at Diamondback, you can look at all these companies, they're just rolling back. The rig count is kind of going down now in pretty much in all the other regions. So if the GOR is going, just changing, where are all the PADD 2 refineries going to get crude from? We sent 4.5 million barrels of crude down to PADD 2 and down to US, and it's all heavies. Yeah. US doesn't make heavy. Yeah. Saudi doesn't make heavy, right? And so the idea is like now, I think regardless of what happens politically, et cetera, the need for Canadian crude for US markets, we're about to go into a 20-year bull cycle. Like I am 100% confident. There's not enough heavy crude to go around. Yeah. The other countries are Venezuela and Mexico. Mexico has been putting water and diluents, sending it back to USGC, like the Gulf Coast, right? Venezuela, nobody wants that oil, but they're opening it up because they're desperate. And then PADD 2, which is all the key states, Louisiana, like the red states, right? Like the Votenberry. What are they going to do when they need jet fuel? They need naphtha. They need freaking gasoline. Yeah. Where are they going to get it from? They're going to have to come to us. And so like this whole sentiment about like, Imperial like announced a whole bunch of, layoffs recently. I think Exxon did too yesterday or something like that.
Yeah, Imperial did for Calgary specifically,
Yeah.
and Edmonton, and Exxon I think today.
Yeah.
They
yeah,
did?
Yeah.
20%.
I think
that was Imperial.
Imperial was 20%.
Yeah, yeah.
I think 20% globally, but they're shutting down most of it. But like, the sentiment's like pretty bearish, but I would just say like those assets are premium top tier assets, right? Like if you look at it, Suncor or CNRL, somebody's going to swap it up, right? And so I think like for the Canadian bull story, I would say go look and buy some freaking Canadian stocks, oil and gas, because it's coming, and it's coming with a vengeance, because logistically there is no other place that has enough consistent, low cost barrels of oil to be provided to U.S. And U.S. needs more now than ever, because like
They're going to build all these data centers. They need power.
Yep.
Yeah.
I mean, the thing is like, and you go into secondary markets, right? Like propane is another one, right? So they're all going to need all these fluids, because guess what? The AI data center is going to suck it all in. Like even if they go with combined cycle power plants or peaker units, right? Then now LNG Canada, not LNG Canada, but LNG, US exports about 18 Bs of gas every day. In 7 days, that's the equivalent of the entire US consumption of gas. That's how much they're exporting to Europe right now.
Oh, wow.
So now you're going to have a battle between AI data centers, right, who want that gas for their peaker units. Then you're going to have LNG Canada, I keep saying LNG Canada. LNG, which is exporting to TTF contracts in Europe, right? And so now you have a mismatch, a battle of gas is starting. And guess who has tons of gas?
Yeah.
Us. We export about 8 Bs of gas, right? 99% of our export goes down there. So it's like bullish gas as well. Like, we got to build a goddamn pipeline for the gas. It's not enough. But secondary of gas, crude and heavy barrels, like drill baby drill, is going to actually end up happening in Canada more than US.
Do you share the same sentiment?
He's much better read into this than I am, but I do. I think that I've been in oil and gas for 20 plus years. Mm-hmm. From a high level view, I think that everyone needs it, and I don't mean like needs it. I mean, if you look at everything that's happening in technology, if you look at population sizes, if you look at the green movement and how people want clean products, and I think Canada's a great place for that. I think we've got really good regulations. I think that we've got a very smart, intelligent workforce. Mm-hmm. It's probably a matter of time. Mm-hmm. You see some of the sentiments that Carney's doing, and again, I'm not a politician, so I don't pretend to be. But I think that right now with what's happening in the States and some of the tariffs that are happening, and it's a good time for Canada to unleash the beast. And oil and gas is one avenue, and there's many other industries that I think that are going to take some opportunity from it. But again, we have to take the opportunity from it.
Yeah, absolutely. On that, bullish on oil and gas, heavily dependent on the big boom in AI and all the energy requirements. When you think about AI, obviously like everything you're talking about, all these advancements and what everything, like there's more than enough money kind of going, maybe not enough money actually going into it to develop all these things. But when you look at the P&Ls of these companies, like they're not profitable. They're not returning what, like, you look at, I'm probably gonna misquote it, but NVIDIA's forward PE is like 240 or 300 or something like this, right? And Tesla's in the same boat. And it's like, okay, you look at NVIDIA, they're $4.2 trillion, but they make a couple $100 billion a year, like not even close to where Amazon's at with their revenue. And then I think they were showing OpenAI is at $12 billion a year, really like a drop in the bucket compared to the amount of money that's getting invested in it. So is it overhyped? Would we see AI get cracked at some point here because it's overhyped and the revenue's not coming, and then oil and gas is going to get hit right behind it because, if investment's falling off of AI, it's going to fall off of energy because it's all back towards that AI and energy generation for it?
It's a very interesting question. There's two parts to it. One, I don't think it's a hype at all, mm-hmm. right? And I'll give you a perfect example. I'll give you one bullet. AI is being bought. Mm-hmm. SaaS is being sold. Mm-hmm. Everybody wants it, right? Everybody needs it. They just don't know where. Like, especially in energy, the verticals, they're trying to figure out, well,
where do I deploy it?
Exactly, yeah. Productivity or EBITDA,
mm-hmm.
right?
Totally.
Or P&L.
Right. That's the question.
That's the question, right?
Yeah.
But if you just look at it at the global perspective, every vertical is going to get impacted. It's just like the adoption rate might be slower, which is totally fine, right? Because there's not enough compute to go around.
Yeah.
Or how do I introduce it?
Yeah.
Exactly.
But I think we saw a similar, like the .com, right? Everybody knew this is coming, this is the next thing. But all of a sudden it was overhyped. All these companies, all this money, and they're like, how are you making money from the internet? And they're like, actually, I haven't figured it out yet. I don't know how to
But I think the bus cycle, and I was part of the bus cycle. I'm old as hell. So I was part of the bus cycle in the late '90s, and I don't think it was a matter of there was a bus cycle, but I think that if you look at what the bus cycle produced as a byproduct of that, I think we're here talking because of this, right? And so it's not a matter of if. I just think it's a matter of time, and there has to be an investment into the capitals to build this technology to see what it can do. Like what's happening right now, it's probably a bit hypey just because people don't understand how to deploy it and bring value from it.
Yeah.
Does that mean you shouldn't do it? Yeah. No, if that was the case, then we wouldn't have the internet, we wouldn't have web pages, we wouldn't have all these so all of these items, they just spurred opportunity for people to say, how do I deploy it? All the money that's being spent, at least in small medium-sized businesses and maybe oil and gas companies today, is saying, let's do some POCs to understand how is this valuable, and if it is, where should we spend time and money to do it? So there's an investment in idea generation, and there's an investment in where do we deploy it that I think you have to do when new technologies like this exist, or when maybe this stuff has been around for a long time. It's commercialized. I think that's the difference. And if you can commercialize it, how do we adopt it? And so for me, it's a matter of time, and even some of the clients that I'm working with, I'm today struggling with now traditionally, and traditionally is AI, standardized AI and ML for oil and gas companies. Should you spend time there, or should you spend dollars on Gen AI and productivity? Well, if you don't know, then how do you know?
Yeah.
You got to make an investment, and so it's no different than these big corporations spending billions and billions of dollars to buy AI and ML and data centers and all of the upstream activity that happens because of it. Oil and gas, Wish talked about that. The pipelines that need to be built to supply power, to supply data centers. But keep in mind, that's only one avenue for power needs.
Yeah.
Like there is power needs outside of data centers that still exist today.
EVs,
yeah, and you can't negate that. And so, if you look at the value chain of what maybe this newer technology like Gen AI and reinforcement learning is doing, it's one customer of many that exist. I think the question is, how big will that customer be at the end of the day, or what is the hype cycle or the capital spend cycle before they figure out this is actually what we need in order to maintain this and deploy it in a way that's valuable.
Mm-hmm.
There's a management cycle too, right? You mentioned about NVIDIA.
Mm-hmm.
There's NVIDIA. There's like a bunch of other ones. Like there's GPUs, there's TPUs, tensor processing units, which Google uses. And it's way better for ML workloads, generally speaking, because they made it for matrix multiplication, right? Mm-hmm. They're the OGs of like ML workloads, but now they're also buying NVIDIA. Then there's like these newer technologies that are coming out, LPUs, right? Like language processing units. Mm-hmm. NVIDIA is like, again, I don't want to like pump it, but what they did really beautifully is that they own the entire vertical stack of so there's like 4 layers, right, of a data center: the compute, the storage and the memory, right? The networking and the power. That's the 4 pillars, really, right? And so they own 3 of those 4 verticals. They just don't own the power yet, right? Mm-hmm. But networking, like they have monopoly relationships with Samsung, with Hynix for memory. And then they have, on the compute side, like the GPUs are built for, they call it graphic processing units, right? I call it general processing units, because if the underlying technology stack changes tomorrow, it's no longer a transform, it's reinforcement learning, et cetera. GPUs are general purpose processing units. They will adapt, right? And they also have monopolized the ecosystem. Like, for example, when I work with AMD chips, right, I hate it because the ecosystem that they've built for me to code, it takes me like 2,000 lines of code to write, right? But it's cheaper. It's not as nearly as efficient. But when I go to CUDA, which is the NVIDIA package, which is the abstraction layer where you code, they've made it super easy for me to integrate and deploy a model, right? So there's a fundy side, which you're talking about, like the PE multiples and all the 4P, et cetera. But then there's look at the moat. And if you talk to anybody, they'll be like, there is no other company that can do this fundamentally, right? And the second thing is their relationship with TSMC.
Yeah.
And then the third thing is the tribal knowledge that they have, right? Like if you look at how all these engineers in Taiwan, et cetera, are doing it, they tried to replicate that model in Phoenix, and it failed because, and I hate to say this, but the work ethic was totally different, right? You know, the Taiwanese chip engineers came here and they would grind out 20-hour shifts because the work had to be done. And then they were supposed to do the knowledge transfer as part of the CHIP Act, right? And so what happened was the North American work style was 9 to 5, clock out, go home, and then the TSMC folks and the chip engineers from Taiwan are going like, "You're going home?" Like, and whereas these guys were like sleeping over there. Like that integration layer is so different, right? Like you can't disrupt it. Yeah. And you're not chat GPTing your way into like learning how to build an NVIDIA GPU, right? Like that documentation doesn't
That's a lot of prompts.
Yeah, that's a lot of prompts.
Thanks for joining us for another Nerdin Out podcast at Cold War. I was joined today with Mike Henry and Wish Bakshi. Do you guys want to tell where people can find you and reach out to you if they're interested?
Sure. I mean, you can find me on LinkedIn. I'm very active, Wish Bakshi. And then I have a website as well that you can click on there. But that's about it. Yeah. Mike?
Mike Henry, I'm from Domino Collective, and you can look me up on LinkedIn, our website, and reach out. Love to chat.
Data in hand, we rock the bytes, and we'll take a stand. Calculators flashing like a disco ball.